Hey guys, it's your pal Dave from notesandvolts.com back for part 2 of the Teensy-Synth tutorial. In this episode, we're going to use a program called Pure Data to make a virtual control panel for our synth. So let's get started. Pure Data is an open source visual programming language designed specifically for multimedia. And if you've used Max for Live for Ableton, you're already kind of familiar with this program because it was designed by the same person. So first of all, we're going to need to install Pure Data on your computer. So go to this website, puredata.info, and then go to the Downloads tab. And what you're going to want is the vanilla version of Pure Data that you can find right here. So just choose the version you need and install it on your system. Once you've got the program installed, open it up and you'll get to the main window. We're going to start a new file, so open File and select New. And that will open a new blank canvas for us. Now what we're going to do is design a mixer circuit so we can get 3 oscillators and mix the individual levels. And this will kind of show you the technique we're going to use for the rest of the synth. So Pure Data is based on objects. And if you go to the Help menu and List of Objects, you'll get this pop-up window that will show you all the different objects you can have. And there's quite a few of them. But I'll show you the ones we're going to need for our application. So first, if you go to Put and you just go to Object, you'll get a blank object. And to make it into the type of object you need, just type in the name of the object. So first of all, we need a Midi output. So if I type Midi out, I should get this little thing, and you'll know it's correct because you'll see these little tabs at the top. And that means it's a recognized object. And this Midi out object is going to allow us to send Midi CC commands or continuous controller commands to our Teensy-Synth and control the various parameters. And that's how we're going to control everything on the synth. So next you're going to want to go to the Put menu and select V Slider, which stands for vertical slider. And here you'll get an object that is basically a fader on a mixer board. Now go back and create 3 of these objects. Alright, next we'll go to the Put menu and we'll select a number object. And that is going to display the output of the fader. So let's create one for each object. And if you get a connection you don't want, just select it and press backspace. All right, and there we go. So we'll connect these to the faders by going over these little tabs. And if it turns, when the cursor turns into a circle, that means you're on an output or an input. And if you click it and drag a line, you can drag it to another input, like this. All right, so now we've got our 3 faders. And if you want to test them, go to Edit and uncheck Edit Mode. So once you uncheck Edit Mode, whatever you've designed is going to be live. So I can now move these faders and you can see that the numbers increase from 0 to 127. And luckily, that's the range we need for MIDI. So MIDI CC commands can output a value of 0 to 127. So this is perfect. And finally, we need to turn these into Midi objects. So what we'll do is put 3 more objects and we're going to type in them CTL out. and then space, and then the MIDI control number you want that slider to represent. So we'll start with 100. And there you go. There's our object. And then we'll put 2 more of those. So we'll make the next one CTL out, stands for control out, and we'll make that 101. And finally, one more. And CTL out 102. Now we'll kind of arrange our stuff so it's not too cramped. There you go. It's not, accuracy isn't that important. Okay, so we'll place a control object under each fader. And then we'll connect the output of our number box into the input of the control device. And that's it. So now we can go to File and save it. And I'll save it as Teensy-Synth Panel 1. Okay, so there we go. We have our panel, and once again, if we put it or take it out of edit mode, we can now use it. And we should be sending MIDI CC commands on controller numbers 100, 101, and 102. So we could do all this with actual controls, but I found using pure data makes it very simple to experiment because you're not limited by the parts you have on hand. You can add as many sliders and buttons as you want. So it's a great way to experiment with the Teensy-Synth. Okay, so now the control panel is done, we're going to need to go back to pjrc.com/teensy/GUI like we did in part 1, and we're going to design a slightly more complex system. So once again, we need to go down to Control and put a SGTL 5000 object. And remember, that just sits by itself. Now we'll go to Output, and we'll select our I2S object, and that's going to be our Teensy board output. Now we'll create 3 oscillators. So if you go down to Synth, we're going to take 2 waveforms, and also a pink noise generator. So to control all these oscillators, we're going to add a mixer object, and you can find that under the mixer section. So I'll pull one of those and we'll put it between the oscillators and the output. Now we've got 4 inputs, so let's connect waveform 1 to mixer input 1, waveform 2 to mixer input 2, and our pink noise generator to input 3. Then we'll take the output of that mixer and we'll go to both the left and right channels on the I2S output. And there you go, there's our system. So once again, we'll go to Export. That gives you the code, and you can just copy it and paste it in your Arduino sketch. Now, I've already done this for you, so you don't have to go through that step if you don't want to. I just want you to be aware of how to do it. So here's the objects that were generated by the Audio System Design tool on the website. And you can see we have 2 waveform objects, waveform 2, waveform 1, our pink noise generator, our mixer object, our I2S output, and we have some patch cords connecting them all together. And finally, here's our SGTL 5000 control object. So let's take a look at this test program. So once again, in the setup function, we're going to set up all our objects. So you need the audio memory command. Here's our control chip enable and initial volume command like we had in the last program. We have our waveform 1. We're setting it to a sawtooth, amplitude 75, frequency 82, and pulse width 15. And waveform 2, another sawtooth. We've created a higher note, a 123 hertz note, and same settings for everything else. Here's our pink noise generator. We're just setting the amplitude to 1. And finally, here's our mixer gains. So we have our 3 channels labeled 0, 1, and 2, and we're setting the gains initially to 1, which is full volume. So the volume range is 0 to 1. Now, one thing you haven't seen yet is this command, USB MIDI set handle control change, and I named the function my control change. So this is part of the USB MIDI handling library. So if you notice in the loop function, we just have USB MIDI read. And that's all it's going to do. As the program loops, it's just going to keep reading and checking for MIDI input. And that's important that you call that pretty quickly because you don't want the input to back up. So this function here, the set handle control change, listens for any MIDI CC messages, and when it finds one, it will jump to our control change function, which is here. Now that function takes 3 parameters, 3 bytes, and remember MIDI is all based on bytes. The first byte is the channel byte, and remember MIDI can have MIDI channels 1 to 16, so if you have different synths, they can all be set to respond to different channels. The next parameter, which is very important to us, is the control number. Now if you remember in our pure data mixer, we assigned the CC control numbers to 100, 101, and 102. And the final parameter is the value byte, which is the number that actually gets sent from each fader. So that can be 0 to 127. All right, so once this function gets called, it will be passed these 3 parameters by the Teensy MIDI library. So it will know what channel it was on, what control number was sent, and what value is sent. Now here I've created a switch statement, which if you've never used is actually a really handy thing. So the way this works is basically it's going to listen to that control variable. So the control variable comes in, it gets passed to my switch statement, and basically these cases are what to do on each number. So if that control variable is 100, it's going to execute this little block here, 101 here, 102 there. So all this is going to do is it's going to set the mixer gain to a value. Now this is mixer channel 0, mixer channel 1, mixer channel 2, just like we had up here. But instead of setting it to a specific number, we're going to set it to something based off this value byte, which if you remember can be 0 to 127. And that's what this little formula is here. Now this formula basically scales an input into a desired output, and we're going to have to do that all the time with that synth, and it's a very important concept in programming in general. So let's look at that a little closer. So to help show you how a scaling algorithm works, I'm going to use an old friend. Okay, so here we go. So let's write a quick basic program to kind of show you how to scale an input into a desired output. So first of all, we'll take our input and we'll assign it to a variable. So we'll just call it in. Now here's where we're going to actually do something with this variable. So what we need to do is scale this variable or change this variable into a percentage. And the way we do that is we'll just take the variable, whatever number we get in, and remember in our example it's going to be 0 to 127 because it's MIDI data. So that's our in variable, and we're going to divide it by the total number or the highest number we're going to get in, which in this case is 127. So that's the maximum input we're going to get. Now I'll just print a blank line, and finally we'll loop around back to the start of the program. All right, now let's run it and see what happens. Okay, so it's asking for our input. So let's start with the highest number we can get, which is 127. And that gives us a value of 1, because 127 divided by 127 is 1. So that 1 represents 100%. So that means 100% of the input is going to be sent to the output. Now, if we take a value of 0, we get a value of 0 out. So if we get 0 in, we get 0 out. But here's where it gets more interesting. So let's take a value roughly in the middle, like 64. Now, if you notice, we get this decimal number, which is 0.50. And if we round it up, it's basically 0.5, which makes sense because we would want to multiply our input number by 0.5 to get our output number. So basically that's 50%, which is right because my input was 50% of the total. Now I could do this for any number. So if I take 22, I get 17%. If I take 88, I get 69%. If I take 100, I get 78%. So it's basically scaling our input number into a percentage of the total. Now, let's try this. Let's say instead of our MIDI data that we're expecting, I'm going to use a potentiometer. So later on, I may want to make a hardware version of this. So you may know that a potentiometer in Arduino puts out values from 0 to 1023. So to change my program, all I need to do is change my maximum input value to the maximum I'm expecting, which is 1023. And now when I run this, you know, if I say do 512, which is about halfway, I get 50%. If I do 1,000, I get 97%. So it still works. You know, I can have any values of input that I want, and I will get a percentage on the output. But there's one thing we have to do. We have to actually scale the output to the range that we want. Now that's very simple to do. So all I need to do is multiply whatever range I want, the highest number I want out, by this percentage that we've just calculated. So let's say I want to control the pitch of an oscillator and I want to go from 0 to 2000 hertz. So I would just take my highest number, which is 2000, and I would multiply that by this percentage. And let's see how that works. And let's also return our input range to the MIDI range, which is 127. All right. Okay, so let's see how this works. So let's say I take my largest number I'm going to get in, which is 127. I get the full amount, which is 2000. So it would be 2000 hertz would be sent to the oscillator. Once again, if I take the number of 0, I would get 0 out. And if I take halfway, which is about 64 again, I would get 1007 hertz out, which is about halfway. And once again, you can do this with any value you want that comes in, and we will get a scaled version of the output. So once again, this is the formula. So what you want to do is take the largest output number you want and multiply that by the value you get in divided by the maximum input value you can get. And that's it. That's the formula. And this is a very handy formula, so I would commit this to memory, and we're going to use it all over our Teensy-Synth program. So get to know it well. All right, so if we come back and look at our control change function again, hopefully this will make a little sense. So the mixer gain is on channel 1 is our input value, which comes through as this byte value, divided by the highest value we're expecting, which is 127. Now, also notice that I've called this value a float, and that's called casting in Arduino. So what we're basically saying is treat this input value, which is actually a byte. And if you don't know, a byte does not have any decimal places, neither does an int variable. So only float variables have decimal places. So we're saying take this value, which is coming in as a byte, and treat it like a float for this calculation. So that way I'll get my decimal places, because if you remember, the value we're trying to get is 0 to 1. So basically we're taking our input value of 0 to 127 and turning it into an output of 0 to 1. Now that we have our program done, remember we're actually using the Teensy now as a MIDI device. Okay, so when we compile our program, we need to go to Tools, and we need to set our board correct, Teensy 3.2, but we need to go to USB type and set it to MIDI. Okay, that's the important thing. That's going to turn our Teensy into a MIDI device. Very important. Leave everything else as it is, and we are good to go. So just send it to your Teensy. And it looks like it went, and everything went fine. And remember, if it asks you, if it says it did not receive the command, you may need to press the button. But this time it actually went through fine. All right, now to make this work, we're going to have to do something, and it's a little inconvenient, but you have to do it. So first of all, make sure you shut down Pure Data, because Pure Data only searches for USB devices when you first start it up. So if it's already running when we convert our Teensy into a MIDI object, it's not going to find it until we restart the program. So shut it right down. And you're also going to need to restart or repower your Teensy board. So pull the USB and reinsert it. And that's going to allow Windows to search for this device and recognize it as a MIDI device. So if you turn up the volume, you should hear this, which is our 3 oscillators. You can hear a low tone, a medium tone, and a white noise, and a pink noise tone as well. So now we can open up Pure Data, and we can open up our control panel. And what you're going to need to do is open Media and MIDI settings and set our Teensy as the output device. All right, so go to Output Devices, and you should have Teensy MIDI as an option now. Set it to that and click Apply. Now, as I move the sliders, you should hear that I can control the volume of each oscillator. So if I bring up the pink noise, oscillator 2, and oscillator 1, and I can mix and match them however I want. Alright, so there you have it. We can now control our Teensy-Synth with a software control panel that we can expand and make do anything we want. And once again, I'd like to thank my Patreon supporters for helping to make this project possible. So that will do it for this part. Make sure you come back for part 3, and we'll look at using a keyboard to control our Teensy-Synth. So until then, this is Dave from notesandvolts.com saying thanks for watching.